1 year back, I would not have imagined where the world is today for sure. And we have seen how Gen AI has, I guess, taken over at least our minds, if not taken over our lives at the moment. One question that has constantly been there is that, is software development lifecycle itself going to be different through the use of Gen AI or not? Spoken to a lot of people. I'm sure all of us here have spoken to a lot of people about this topic. In particular, I've spoken to the two gentlemen on the call on the screen here, and the intent is that if you're an entrepreneur, of course, building your own company or maybe in the dev space yourself, what does Gen AI do to impact the software development life cycle is the intent of the discussion today. I'm actually going to begin with a slightly negative question. Either of you are welcome to take the question or build upon other person's answer as we sort of go through. But on the coding side in particular, at least, I've spoken to a lot of people and I've found like two schools of thought. There is one school of thought that is saying that, look, it's going to change software development as we know it. And there is another school of thought that says that, look, any real coding is such a hard act that generating code through AI is probably more going to be a pain than of use to developers, because you do something, it'll still be sort of half-baked, and therefore just the reworking is so painful that they might as well just write from scratch. So I've met both sort of detractors as well as sort of supporters or supporters of this concept. I know where you stand. Actually, that's not a question. I'm more curious to know, why do you stand where you stand, and what aspects of software development lifecycle are you think are the most ripe for disruption?
Do you want to go first? Please.
Yeah, okay. Sure. Actually, as you started framing the question and specifically spoke about people who say that, look, this is, this just doesn't work. I would actually tend to agree that there are certain classes of problem where if you try to use this is more pain than otherwise. But we are at the precipice of this particular technology, and it reminded me of when I started interviewing at different companies in 2005. When you are interviewing someone, there used to be a typical question that, should they have internet access or not during the interviews, right? And of course, at this point, like nobody really questions that, like you are supposed to know how to use it, right? Then the whole part of like, oh, should they, if they refer to something from Stack Overflow, is that, is that cheating? Is that okay? I think at the end of the day, where we settle down is, look, if the work is getting done, ultimately you're able to move around. That means you know which tool to use in what way. Now, the real problem is when you use those tools the wrong way. So I don't think you're going to meet anyone, certainly includes me, and I'm going to take a leap of faith that Dipanjan also stands on the same side, that somehow your LLMs are going to come and write every possible code that you ever need for any unknown scenarios. That's surely not going to happen. Really, I think all of us are in this space who are trying to figure out that, look, we have this promising technology right now. In certain mental models, it works in certain way. We need to find the right places, tooling, interfaces, feedback loops that solves some slice of the SDLC lifecycle. Now, the only question is how big that slice is. And I think, honestly, I also, depending on what was the last night's debugging session look like, will wake up in one school of thought or the other. But I still believe in the feasibility. It's really about identifying which problems to solve. It's not about programming in general, right? But that's like a very short answer as to why I believe that it will work, as long as you find the right problems for it.
I largely agree with Aakash, right? Look, and at first to your framing, right? I think as you said, we just came out of Stealth yesterday. And the first set of reaction that we got, like overwhelmingly positive reactions, but we also got some stuff around that, right? Example would be some user made a video reviewing us, right? Some influencer on YouTube on their own. And one of the comments that stood out for me in the comment section was a soft front-end developer saying that I tried the tool, it's very cool, but I'm afraid that it will replace me in the job, right? So I get the question, right? But my personal viewpoint and our viewpoint as an organization is that that's very, very unlikely to happen, right? So what I mean by that is I do not think, so first of all, for context, people who do not know, at Kombai, we are trying to come up with a new uh, ensemble model that can understand designs and generate code from itself, at least the UI code from itself, right? So this question is sort of very on point, very relevant to us. Our view on this is that it's very, very unlikely that we'll be able to generate, or anybody will be able to generate code that is identical to what a human being writes and can go into production straight away, right? And that's not even goal. That's not even a goal that we are pursuing, right? But I think what is realistic and likely to happen is that we can provide a bunch of stuff to the front-end developers. In our case, that is code. In somebody's end, can be test suite, right? In some other cases, that's be documentation, right? But which will be a good starting point, right? Or maybe even 80% of the work done. So especially on the more mechanical side of things, right? For example, documentation is a prime example for that, right? And a lot of sort of this has already happened. Like if you think about boilerplate code, right? Like nobody writes boilerplate code from scratch today. It's not really intelligent in some sense, but at least because it's so procedural that people have been able to automate. So I think more and more, like if I go to your next question, right, which is around what are the places here that are more likely to get automated, right? I think more procedural some work is, I think probably more likely that whatever you call this technology, right? Generative AI sounds like a little bit of sort of, to me as a more hacker news person than a product hunt person, it sounds like a bit presumptive to me to call this AI on the first place, right? It's been so abused by marketers that I'm almost a little bit afraid to use it. But the idea is that I think whatever you call this technology, right, it will get more intelligent and it will start from the bottom of that intelligence pyramid, if you will, right? So it will start with more mechanical stuff, right? So today, probably for plain HTML, CSS, React component sort of stuff, something like Kombai could do very well. Over time, we'll get a little bit better, but we'll probably never become as good as a real human being. So probably it's going to be about all these technologies come together and really helping developers to get better. I think just at the risk of becoming too long an answer, I think there is also a second component of which developers can use this, right? So whatever these technologies are, probably not all the developers in the world can use it today, right? So especially for, imagine that developers in large organizations, they will have so many specific things to abide by, specific frameworks, internal tooling that they have to code with. It's realistically not possible for them to use this by and large, right? But at younger organization, even today, probably they can use a bunch of this, right? And make their lives better. Over time, we'll see that change a little bit as well, right? But again, two axes literally, right? One axis would be maturity of an organization and how much customization they would need, more customization they would need. Probably these sort of tools can work less. And the other axis would be how procedural a task is. If a task is very procedural, probably this can do better, and less procedural becomes longer the time frame would be.
Yeah,
does that make sense?
I like that particular two axes that you're mentioning, especially the procedural part. So in a way, I think we are both, and I think that's the point of inviting the two of us over here. We are on the two opposite ends of the spectrum of what we are targeting, right? We are actually going to the other extreme of saying that, look, we are looking at a medium-sized IT services companies,
right?
And that's what we are focusing, which will have a lot of internal policies, processes, so on and so forth. And which is also where we will not be focusing maybe so much on the deep tech, and which is why when we are positioning ourselves, or as we will position ourselves, it will be focusing a lot more on the overall end-to-end SDLC lifecycle, because from an overall value delivery perspective for that team, the amount of time that you end up spending in writing code is not the majority time, right? That's one aspect of it. Second thing is, the more structure you have in the organization, which is you will typically put that under the headers of either templates that you're following, playbooks that you're following. There are policies that are created for someone to follow when they're doing that kind of a work. And there is an institutional knowledge which typically gets passed down through training people by giving them some sort of a playbooks or mentoring, right? These people, there's a lot of institutional knowledge that sort of gets passed in. What we have been able, as programmers in the past, what we have been able to capture is things which are absolutely deterministic and easy to model. What I believe LLM allows us to now start scratching the surface on is actually this institutional knowledge and the playbooks, where it can pull all these things together for as simple a task as possible, and then dramatically improve the productivity over there. So in a way, you can go for less structure, less constraints, or you can go with far more structure, well-defined, where the same activity happens again and again and again at a very large scale. So when you're looking at, let's say, some sort of a run project, which is your typical maintenance sort of projects, which are running for 5 years, the underlying technology stacks are not really being developed at that faster rate, right? The procedures don't really change, your SOPs don't really change, you have a lot of past data. Your ability to then add value in those tasks is also dramatically higher, because you can actually tune that LLM for a particular task. And when I say LLM, I don't mean just the LLM. I think there's a lot of system too that you have to build on top of it. It's a combination of your LLMs and your system to get tweaked for one particular task. And as long as the task is happening in sufficient amount of quantity, your ROI on that investment might be worth it. But you're fundamentally looking at reducing the complexity as much as possible with as much either structure, or just saying that, look, I'm okay with the open-ended aspects. That's the spectrum that we land on.
Dipanjan, a question to you. At least in your journey, how did you overcome building a code generation tool that aligns with, let's say, what the developer wants? What are the company's internal style of writing code? What are the project's requirement? How did you overcome those challenges?
So first of all, it will be an overstatement to say that we have overcome those challenges, right? We are in very early stages, but I think first of all, just for context, obviously Alok and Shayantan knows this, they know this, but for the rest of the folks here, so Kombai essentially is not working on LLMs, right? So we use generative AI very loosely as a statement because that's what most people have mental bandwidth around today, right? But essentially what we have built is a bunch of an ensemble model of a bunch of deep learning and heuristics models, and probably a little bit of LLM, very thin layer, like 5% of LLM that come together to generate code, right? And like in some sense, you could argue that when people say generative AI today, the natural sort of alignment is with LLM, but there is no real reason for that to happen, right? Like any sort of algorithm that generates something from a bunch of instructions, right? That can be called generative AI. And if I go with that sort of definition instead of interpreting, let's say, plain LLMs as generative AI only, right? Then I think first thing that we did, and that falls in that bucket, is that we built custom stuff, right? So like it's very difficult to, let's say, train any generative AI, right? Like imagine Llama, trying to train Llama for a particular task. It's nightmaringly hard. Last month, I sort of attended an event at OpenAI office in SF, and that was the theme there as well, right? Which is that you can probably nudge OpenAI with vector databases a little bit for classification stuff, but for everything else, training is practically impossible, right? You will hear a lot of sort of buzz today around training LLMs, but for all practical purposes, nobody has been able to do it, right? But instead, what might be possible is that you might either do what Aakash was talking about, which is build layers on top of that, which can essentially build better instructions, right, that LLMs can work with, or sidestep LLMs altogether and try to come up with new sort of models altogether that can work for a specific task, right? So on that end, particularly, I think what at Kombai we have done reasonably well till then is that for the task of understanding design files, like UI designs that are made in Figma, how to understand that intelligently is a problem that we have, I would imagine, made a significant amount of progress on. That is by building custom models. Specifically, deeply integrating with customer stack, that is something that we are just starting to scratch surface, but that is probably going to be more of a procedural bunch of code than sort of really intelligence, new model sort of stuff, right? What I mean by that is, for example, if we can understand from a UI design the particular component is an accordion, right? I think that is where you will need an intelligent model or intelligent algorithm to come in and understand that. After that, mapping that accordion to, let's say, Gojek's accordion in their front-end framework, right? That's a more procedural code. We have not really done that, but I imagine that can be done as and when we sort of keep on maturing as a company, right? So short summary, just to recap, is that at one end, wherever you needed to understand stuff that current LLMs cannot understand and instructions, we have essentially built our own models. Wherever either we need deep integrations with particular tech stacks, we have written some procedural customization on top of that, We'll keep on adding more and more such procedural customizations with an aim of sort of being able to integrate better with individual tech stacks that exist in particular companies.
Hi, Amrit.
Hi.
So, Amrit, will be great if you can introduce yourself and also ask your questions.
So hi, I'm Amrit. I'm a founder of a company. For the last 2.5 years also, we have been trying to solve the same problem. And we earlier, before GenAI, we were trying to come up with a very high level language, which anyone can write in, and then the details of the software are figured out by mathematical optimization. But as GenAI came up, so we are able to using that.
Yes.
Yes. So now, what do you guys intuitively think would happen? Because we are going to abstract out complexity, and someone is going to write code at higher level than they are writing today. So if you are abstracting out complexity, the end language, which would end up being the interface the person will use, would it be like language or would it be like mathematics? Because programming is like mathematics. It's procedural, it's constraints perpetuating, and language is more subjective. So what intuition do you guys have? Like what that interface would look like?
I have personally struggled with this problem. So one of the things last year, like this is before, like LLMs came to my attention. Rather, I would say for last 3 or 4 years, I have been tinkering around this problem, which is, I've majority of my life I have worked on backends, right? So I went into doing more managerial sort of work. Then I came out of that saying, I just want to go back and start building something. And I realized that the front-end technologies, overall databases, since I stopped coding, then got back into coding. Whereas the backend infrastructure, sure, man, you had a lot of some lambdas and stuff coming up, and that's pretty much it, right? I'm like, no, there has to be something, right? So let's figure out some sort of no-code solution for backend, right? Because say you have no codes on the front end, you have no code on the databases. So you had like the likes of Retool and Bubble and God knows how many who are basically helping you do that. You similarly have no code on the backend, which goes all the way from Firebase to Airtable to Hasura, so on and so forth. If you think about the limiting factors here as to why it works this way, there is a visual deterministic representation that the code can look at and that the human being can look at and say that, look, we agree, right? And this is it, like this representation works, and which is where you are able to build out higher and higher abstractions. When you are working on the backend code specifically, first of all, there is no visual representation. I mean, sure, people have tried since like 60s of the UML diagrams and so on and so forth, right? But the problem is nuance is always in the details. So me and my co-founder, the current co-founder, we used to keep fighting because I keep trying to do this. I'm a mechanical engineer, by the way, so not a lot of hardcore science, comp science background. He's a comp science guy. He's like, look, you're being stupid. He's like, the most compressed representation of logic that we know for the last 60 years is the programming languages that we use.
Right.
If you are to abstract something out of it, which means that you want a less verbose way of representing it without losing the details, it just doesn't exist. What are you trying to do, right? And I still struggled a lot because I didn't want to give up on that particular aspect. But I have come to accept it a little bit. And one of the reasons we went into LLMs is like, look, I finally found a way where earlier, say, the reason I was excited, sorry, this is a bit close to our topic for me, right? So one of the reasons I was trying to work on the no-code side, or anybody's working on the no-code, is to reduce the barriers for you to do the programming and generally reduce the grunt work as much as possible. Now, doing that on top of a traditional code is really, really hard because you need someone to confirm whether what is done is right or wrong.
Makes sense.
And you're trying to attack that problem from one side. LLMs actually allows you to attack that problem from the other side, which again does not really remove the developer at all from the overall space, and I will come to why. But it still allows you to reduce a lot of knowledge work that happens in the SDLC cycles and make sure that the noise is lower. Now that's the point. Now noise needs to be lower. If the LLMs increase noise, nobody will use it, right? But yeah, the real problem is someone needs to confirm and say that yes, the written code is correct. That has to be a human being because legally speaking, no other tool or nobody else can take accountability for a fuzzy system which is probabilistic. So legally speaking, you will always need someone to take accountability that, look, this code is correct. That person is human being. And for that person to verify, it has to be a programming language, because otherwise you lose details. So sure, some workflows you can optimize. There are some flowcharts and state transitions that you will convert into visual systems. So some bits and pieces will come out in better abstractions, which let's say even the LLMs understand and you understand, you can speak on top of that. But ultimately everything gets converted into code. We don't have a better representation for it. It is what it is.
I absolutely agree with you.
Because you have a visual side of it.
Yeah. I was just going to chip in with that. So Aakash, I agree with your statement, right? But I will point out this on the first part of the statement. If you think about even retools and stuff like that, but you would assume that the visuals are a good representation of what has to be in the code. I personally do not know of one company that can use retool or any bubble or any of these, right? Apart from prototypes and internal tools, right? Where essentially the expectation from code is very.
Right. I mean, even for that matter, so I have extensively used Retool in my previous term. All of our internal systems were on it. I love that particular product, but ultimately the users were developers.
Right. But also that's possible. Even that realm, right, where internal tool developers, which typically is a separate team or inside organizations, can use Retool, is only limited to, let's say, internal tools developers, right? One reason for that is human imagination, right? What I mean by that is, like, if you think about something that sounds very procedural, like UI, right? The amount of innovation that has happened in UI over the last decade is mind-boggling. Like, look at Cred's app, right? Like, or Airbnb, or like you can pick up any of the 5,000 people who really do good UI, right? So basically, Amrit, back to your question, another thing that changes quite fast here is that what human beings are able to imagine, right? And I almost think that even if we collectively can imagine a system which is significantly better than code in terms of sort of interpreting that, right? Like, it's very difficult, almost practically impossible to happen, as Aakash already sort of pointed out. But even if that existed, I would almost imagine then after that, the human beings who create requirement documents, right? Like PMs and designers, or like for backend system, front-end guys, right? Like whoever creates requirements, they will go one complexity above that, right? And now with something that will need more complex stuff. Right? Because
so you can have some abstractions on which you can collectively iterate with other people, right? Like that's what UL diagrams are supposed to be. That's what prototyping tools are supposed to be. So yes, you can have those abstractions on which you can iterate with other people, but ultimately when the rubber meets the road, you want a deterministic thing which you know for a fact it works exactly one way, and it's not going to have bugs.
So to summarize again, Amrit, right? My personal opinion is that I think that a world where a PM writes a bunch of text and the software gets auto-generated from that is extremely unlikely, right? So you will need, that's my intuition. Like, only future can tell us what this is, right? But that's my intuition.
I do want to build on Aakash's comment actually, and I think which is, I never thought of it this way, but listening to him, I think one of the unique things then, Dipanjan, in what you are doing is that you are not trying to give an abstracted version of what you want machine to do. You're actually giving it the full detailed truth version in the form of a visual, right? Number two, I think what Aakash said is also very insightful, which is that how do you know whether what you are generating is actually the truth? And because you can now generate from the code that you have generated, you can generate back the visual, right, and you can do a diff with the visual. Right. You can see whether how far away from the truth am I. Right. So I'm just trying to think that this visual input that you are doing for front end, is this an exception therefore, or are there many such situations where you can use actually code generation?
Look, my intuition again is that this is not unique to front end, right? To be honest, like each one of these will be complex problems, right? So for example, when we started with exploring this problem in front end, whatever we thought is likely to be the solution or answer space, right? I think all of those has turned out to be wrong now that we are 16 months into the problem. So the point I'm trying to make is that it will be very difficult to come up with, let's say, 5 minutes answer to these questions, at least for me, without knowing this deeply, right? But my intuition is that it is not unique to front end. I think every bit of software development lifecycle, we will see promising companies that can use intelligent algorithms in some way, either raw LLMs or stuff built from scratch, right, to make developers' lives significantly better, right? I think, and that's not new, right? So if you think about the last 5-10 years of software development, right, software tooling has always happened with the goal of making software developers' life better. But in spite of that, number of software developers in the world keep on going up because there is more and more complex software to build. I think both of
general law, right? As anything becomes easier or cheaper, the demand increases.
right.
Yeah, in fact,
So
sorry, I'm going to make a comment on this one again. I mean, Shantan and I met a very good VP of engineering in the Bay Area earlier this year, and he gave a very good analogy, actually. You know, if you, and I'm building one analogy on top of it, and then I'll give his analogy, which is that imagine when tools like WordStar, I know that most people on the call didn't exist when WordStar came out. This was back in 1985, 1986. It was
I would have to confess I do not know what word study is. You'll have to.
Okay, WordStar is a precursor to word processing. Before Microsoft had Word,
I see.
it was WordStar. And if you know most of these, if any of you use Control C, Control V, Control C, Control V was first created inside WordStar. And that's where we are. I mean, so those shortcuts have actually come from WordStar originally, in fact,
Wow.
where they're coming from. But the threat was, if you remember at that point, being a typist was a job. And everybody thought that, oh my God, these typist jobs are going to go away because guess what? But that's not how the world works. The reality is that today, out of the 8 billion people, probably 4 to 5 billion are typists today. Right? And this friend of mine was giving the same analogy that the world today has 30 million developers.
Yeah.
We don't have to worry about whether the job of 30 million developers is going to go away. Our dream is different. Can we have 1 billion developers tomorrow is the way we should be thinking about this. And I think this is probably what, or this enablement is probably what we are sort of going towards here. I mean, Amrit, you can ask your second question because I'm not able to comprehend it. So please articulate in your own language.
Yeah. Hi. So my second question is, have you guys checked out Cursor.so?
Amrit, I'll be honest, I have not seen this before. I'm looking at the site now. I have seen a bunch of tools, similar tools before, but not Cursor.so particularly.
Okay.
Yeah, I had also just gone through the website when they launched. But I mean, I can imagine what it is because there are like quite a lot of similar plugins. They're effectively competing with VS Code over here, which is fascinating.
Yes.
I mean, the balls, man. Yeah, I've seen it. So your question is...
like, do you think, like, what is your opinion? Is this the way to go? Like,
I would say yes. I think directionally speaking, yes. The more integration you have in the whole ecosystem, the better it is. It has its own set of problems as well, right? But whether it is your like multiple code bases, whether it is your environment, whether it is documentation, whether it is your Jira tickets, the more your AI, for lack of any other better word right now at the moment, is aware of all of these things, and for a very well-defined set of tasks knows how to put all of this information together, it can do that much better for you, right? So, I mean, that's in principle is absolutely true. The real question is, as the amount of data increases, the noise can also increase. And
Got it.
the amount of data, like the number of integrations increases depending on how well structured that data is. Look, LLMs are fascinating at a smaller scale for processing unstructured data. But if you start giving large amount of unstructured data and you expect them to make the same sense that a experienced human being on that particular domain can make, that's really hard. Like one of the reasons we actually have narrowed down on the IT services companies and that mid-size IT services companies is that they have already built the scaffolding in which large number of people can come and go, which means that they are depending on the institutional knowledge that is codified into their existing processes, formats, tool chains, everything. So the amount of context an individual person needs to maintain, like how much of a snowflake person, right? So there are teams where you have people over processes.
Yes. Yeah.
for a smaller company, that is exactly what you need, because honestly, you don't have one particular process that you know for a fact works. As you cross a certain threshold, you go towards company, which is basically processes over people, because they're saying that, look, I can't have predictability that only these many people will stay with me for 10 years to do something. We need to build far more resiliency towards people. And that's the journey of any organization. Doesn't matter which industry they are in. At that, so there is a particular threshold and a set of tasks where now the surrounding context that is available to you, you can use it in fascinating ways.
Got it.
Again, as I said, it's really about identifying the right problems. This is not one solution that will just work everywhere, right? It's not going to happen anytime soon.
Hello, can I ask a supplementary?
Sure, of course. All yours, please go ahead.
What percentage of the process would you think would be human in the loop? If you want to say automated X amount of software, like what percentage do you intuitively think would be a human in the loop? Like what percentage of the lines would be looked at a human out of the total lines of the code written? And secondly, like what skill set would we be able to get a less experienced coder to do the human level check on something previously a higher experienced level coder would do? Like would we be able to reduce the expertise as well as the number of lines the human has to review?
That's a really hard one, honestly. So part of what we are working towards is figuring out how do you make reviewing easier. Because let's say if you are going to generate a lot of code, which you still expect some human being to review, nobody likes to review. And reviewing code requires higher experience than writing code. So unless and until you are able to develop the tooling that reduces the noise, generating more and more and more code is not going to help. I mean, it looks cool, but as you start using it, people just get tired. Like reviewing someone else's code is a very hard thing. So then the question goes to like, how do you pick problems where you will have some sort of objective criteria by which you can review these artifacts? It can be anything. Say, one of the reasons I love programming or like coding as one space to apply this in, unlike pure play text, programming is where it's objective, right? It's deterministic. You can tell whether a particular functionality works as per the given specifications or not. You can then assume that, look, this is how I'm testing things. And which is partly why your whole SDLC cycle of like QAs and having someone write those test scenarios first, developing, doing some sort of a test check, then you have like a unit test, then you have integration test. The whole system exists exactly for that. If you are able to tap into those systems, you have a higher chance of making these LLMs a larger part of your workflow. By the way, when we look at applying LLMs, I think there are, I would say there are two interaction modes there, right? One is real time, where you are basically you are in the ID, you are in VS Code, whatever, Grammarly, choose anything that you have, where you have real-time feedback with a very short intervals on a very small code. The challenge over there, though, is as your context goes on increasing, the rate at which you will get the response has to keep going down. If you are going to add more validations behind the scene, then again, your response rates will go down. So anything that is real-time integration into your environment will be limited to doing relatively shallow, well, shallow is a very wrong word over there, but anything that responds back faster, that's hard constraint that you have from a UX perspective. One of the things that we are exploring is that where can I actually go off into a background job and actually do a lot more grunt work in terms of multiple levels of validations by taking different data sources, writing tests around them, doing things which comes back almost like a junior developer will come back with the first draft of something to be done, right? That is a very different mode of operation, which again will work hand in hand with anything else. These are not either or, by the way. They both will exist.
Got it.
Go ahead, Shantan, if you have a question.
So there is one more question from the audience, Mukesh. He's traveling, so I'll ask the question on behalf of him. So Mukesh, for Mukesh, the question is, the quality of output from the LLMs actually depend a lot on the underlying contextual data. For example, documentation, system configurations, rules, and a lot of other things. Do you have any thoughts on on what accounts can, in which ways can Gen AI actually help in improving the quality of this underlying data itself?
Jonathan, I have a really odd thing to start with first, right? First is, I think it might sound odd, but my first stab at that would be I do not think LLM performance depends a lot on data, at least the data that you would use as a individual LLM user, right? By and large, what you have said is that LLMs probably need, like if they can be nudged towards a particular data thing, right, particular sort of output thing, you can do that with a relatively small amount of data, or you would not be able to do that at all because their mother load of training data is so large and so huge, and OpenAI has fed or Facebook have trained them on so much data already, right? Like even a few million lines of code is probably not going to be good enough to train them, right? From a training sort of sense, right? What you can use this data for, to Akash's point, is to sort of frame instructions or prompts better potentially, right? But at least today, the consensus seems to be that LLM performance does not need a lot on training data volume to any extent that we can train those LLMs, right? Like what the fundamental model companies can do is a separate question, right? But as a small organization, realistically, I do not think that like the quality of data matters a lot apart from trying to come up with questions itself, right? And now, if I interpret them in the second way, right, which is that can LLMs help in coming up with data that can help us frame those questions right? My intuition is that more often than not, this data has to come from the specific problem segments and has to be from real world than being LLM generated, right? Like I imagine that to write documentations like a company's way, the company's documentation is probably the training data, right? I cannot imagine being able to use Gen AI to generate documentation that will be fed to another Gen AI to do something, right? I remember this craze around whatever you can stitch together with LangChains. AutoGPT was a craze 10 months back, right? None of that has gone anywhere. I really, really struggle to imagine that world more, right? So at least my current narrow worldview would be that you will need some sort of training on human-generated data to be able to prompt LLMs better. And then the fundamental LLMs, I think search is an exception. Probably for search, you can do a bunch of things with search and classification. You can do a bunch of layering, either with vector databases or other stuff. But for most of the open prompt sort of problems, I think that's probably the best that we can use external data for. Aakash, for you to continue.
No, I think I fully agree that if you're talking about fine-tuning for a particular task, if you are planning to go really far from the current output, I think you have a really hard problem. You can nudge it slightly, you can tweak some of the biases, but not by a really great degree.
Yeah.
So that's one. For that though, I think based on what we have seen, I think recently the quality of data matters. But again, you are doing fine-tuning over there, right? And there is a reason why it's called fine-tuning. It's fine. That's it. It's very fine. The second part though is in terms of context generation, I would agree that you are, say for example, some of the things that we are working on actually is unit test generation, right? So there are traditional algorithms for generating unit test cases for static code bases, right? Or static languages, basically. The way those work is very different. I mean, a good way to explain this is they have exact idea of your AST, and because of that, what operations are happening, which primitives are being used where, which classes are being used where, and they can do a lot of permutation combinations to come up with like thousands of branches, and then you use various algorithms to prune those branches and say that, you know what, these are the tests that gives me the highest possible coverage, and there are quantitative measures that you can use to say that, hey, this particular branch is better than this particular branch, right? You can do that. It works pretty well. Interestingly, it generates ridiculously bad method names, code names, and it never, because it can never truly understand the intent of the developer. It understands what's written. It doesn't understand, it can never describe, for example, what the code does, right? LLMs are exactly the opposite. LLMs will actually not have a deterministic understanding of that code, but it, again, for a lack of better word, understands it. So now, which means that it can explain what it is doing. It can explain that, hey, these scenarios should be handled, not handled. Now the vanilla one works to some degree. The question is, if you want to improve the accuracy, relevance of these tests, how do you do that? This predominantly depends on what kind of context you are able to share in that given prompt for a method for which you are generating that particular test case. The richer the context, the better it is. The more so we internally just call them considerations, right? So if you are writing test cases for, let's say, something which is scheduling like a background job, and then that schedules something. As an experienced developer, I will want to think of certain scenarios in which this matches. Now, of course, the LLMs will cover it to some degree, but not all. And this is again where the institutional knowledge comes in. So one of the ways we think of what we're building is we are actually trying to codify institutional knowledge as much as possible into our system, where the combination of the general creativity that, let's say, GPT-4 brings to the table, plus our own specifications, plus our understanding of the code base, all of this put together allows us to generate actually far higher quality test cases, which, by the way, you have no idea whether they will compile or not, right? Because it's GPT-4 writing that particular code. Then you go into a completely different background process where you actually run that code, see why it is failing. How do you want to fix those test cases? Many of those you actually fix programmatically on your own. Some of those you have to go to LLM. It's almost like a developer's workflow that you are trying to instrument in that whole space. But anyway, the point is, in this particular context, your quality of the data and understanding of the code, understanding of the use cases, the way you can classify that, all of that makes a big difference to the output that you are getting. So in that regard, I would say the quality of data is necessary, not in the traditional ML quality of data where you have like crazy quantities of data and somehow that is going to help you. That doesn't work.
Aakash, I do want to, I have a question on your comment, and will sound a bit stupid given that I don't write code, but software testing is one of the areas where a lot of people have talked about that, look, software test case generation, probably something where Gen AI can play a role, right? Now, while you said that LLMs can understand code, I have two questions for that. Number one is that early in the discussion, you talked about how difficult it is for anyone to generate logic from, let's say, a textual description, because to really write the right kind of code, you literally have to give it the logic itself, almost. Yes. In some ways, you have to write a language as a prompt to generate that. And therefore, if generation is so hard, why is understanding it much easier? The reverse way around, if I may take a flip side to it, it's not clear to me why that is an easier computational problem than the other.
When you are summarizing something, you are by definition losing details, which is sort of okay because you are compressing it in a way. But if I want to give perfect instructions, I have to give you only code. There is nothing more condensed than that. I'm going the other way around because code in a way is the source of truth for me, which means I have far more granular source of truth already present. Now in all of this, you are assuming that the code is correct, right? But going the other way around where I'm saying that I have this blob of text or I have this diagram which represents all the details that code will represent, that's just not scalable for all possible use cases. Does that answer your question? Sorry.
Yes, partly, but I'm going to actually ask my second question instead, which is that one methodology is to read the code and generate test cases. The other is to go deeper into the context of that by going actually upstream. So, for example, if one were to go to the PRDs, etc., which actually give the context a little bit more, what it interfaces with, etc. And again, I don't know how easy or difficult will it be to understand that. Will it actually lead to better quality test case generation? And in general, is upstream documentation and process orientation far more important to generating or creating these downstream efficiencies, therefore?
Yes, I think that's partly what I was focusing on earlier as well, right? So when you write test cases, when you use the traditional algorithms for writing test cases, you are just looking at the code. It's almost like in the calculator code, let's say I have divide by something, right? Like some implementation is there which doesn't really take into account the divide by zero error. Let's assume very simple. It will look at that code, see what it is doing, and then only generate test case saying that whatever it is doing, does it keep doing or not? That's what it tests for. But when you give that particular method to an LLM, or let's say you give the specification to an LLM saying that, look, this is what it is supposed to do. Now think of all the happy paths, think of the edge cases, think of the sad paths, think of the scenarios. But this is how a QA would do it, right? We'll look at the specification, think of what all things can go wrong. QA doesn't have to look at the code to decide my test suites. They do it first by understanding the requirement, then go and figure out how do I test this for a given method. And that's where they will write those unit test cases. So we are literally going the other way around, but your ability to cut across the boundary between the two is critical. I think this is something Dipanjan earlier mentioned, and I want to highlight this. Anyone who is doing the kind of problem, let's say Dipanjan and I are working on, LLM is not going to be 90% of what you do. I think it will be smaller. You really need to understand the problem space that you are trying to solve. There is a lot of existing traditional programming ways in which you try to attack those problems, because those are all deterministic. Anything that you can solve in a deterministic way, you should never ever use an LLM because it's probabilistic, right? So I mean, sometimes it'll work, sometimes it'll not work. It adds more complexity. You really go to LLMs for doing only those things which are impossible to do in a traditional. So it almost adds as that supercharger of whatever the underlying functionality is that you're trying to build. Right. And yes, there are times when you can rethink the feasibility because of these capabilities, right? But yeah, it's not the full picture.
And Aakash, actually, that's a great point, right? And I will just provide one example from our experience. So the only problem, so if you think about that whole thing that we're solving, which is, can I look at a Figma design, understand that as a developer rule, and then generate high quality code from that, right? There's only piece of that we have actually been able to use LLMs in any meaningful way. That is to generate class names, because that's a very indeterministic problem, right? Like you'll have to look at the content of everything that is inside the table, right? And figure out a name. And there is no formula in the world for this, right? We tried like bunches of formulae. We'll always take to the developers. They will say this is utter crap. Like nobody else will do that, right? But you throw that at LLM, a slightly fine-tuned LLM, and they magically do something. Who knows what it does, right? But it does something and throws out a name which at least reads like a human name, right? So that's an example of a problem which is very difficult to sort of deterministically solve or even algorithmically solve with traditional deep learning stuff. But you throw out this big box machine called LLM at that, and it does something that works better than everything else, right?
Got it. Maybe Shantanu, you can take one question from the Q&A panel, and that's probably about the time we might have.
So the question is to Dipanjan. And this is from Sri Krishna. So Sri is asking, what is going to be the long-term vision of Kombai? Is it going to be a AI IDE for front-end developers? And of course, Figma also released a VS Code plugin, which is going to add some code completion capabilities there as well. So how are you thinking about it, Dipanjan, in the long term?
Sri, thanks a lot for that. Great question, as always. First of all, our vision is not really around trying to come up with an ID. I think there are a great number of great ideas out there in the world. We do not want to add to that chaos. What we are trying to do is, however developers produce code today in whatever ID, can we produce code that can fit into that, right? I think Figma right now, they do not generate code themselves to the extent that we understand. They have no plan to generate code themselves in the near future. What they have done inside their dev mode is they've integrated with a bunch of Figma to code plugins, which have been available for the last 4 or 5 years at least, right? And you can use them to generate code within Figma in that dev mode, right? To the best that we can say, and obviously I'm biased, so take this with a pinch of salt, but I would bet my life that if you go to your front-end devs, say add factors, for example, right, and show them the code that the Figma to code tools generate, they will sort of throw this out in under a minute, right? So that's the state of sort of current development there, which is Figma is a great tool, but either in VS Code or in web app, they can't really generate code either by themselves or with any of these Figma to code tools. And we are trying to solve that, right? Now, there is a fair case to be made that we should have a VS Code plugin. We actually started with a VS Code plugin, right? And there is a fair case to be made that we should have a Figma plugin, which will generate this code inside Figma. We should probably do both. We have just not been able to prioritize either. Instead, the path that we are taking right now is that you can extract the code in just one click, and then you do that anything that you would like with that code. You open that in VS Code, you open that whatever ID you want, go to Vim and open that up for all that we sort of care about. So we give you the code, you have complete ownership of the code, and you do whatever you want to do there, right? And our, I think, primary vision, like tooling aside, primary vision is how good a code can we give you, right? Can we, like, the long-term 5-year vision would be, can we give 100% front-end and full-stack developers 80% their UI code, right? I think that's sort of the way, and once that is done, we can think about the next step vision, but I think that itself is a large enough problem to keep us busy for many, many years, and it's a very large market. So that's the problem that we're working on.
Again, want to thank everyone for attending the session today. If you have ideas on what topics to cover, please do write to us. And Dipanjan, congratulations on your recent sort of coming out, if I may say so. And Aakash, we are waiting for you guys to come out sometime soon as well. All right.
Thank you for having us.
Thank you so much.
Bye-bye.
Bye-bye.